Hi everyone. With the threat of a second wave of COVID looming, I thought I would show how to make bleach from various household supplies just in case the store runs out. You're going to need a source of electricity. I'm using this 6-volt lantern battery, but a power supply would work just as well. If you're worried about the power going out, these guys are very handy for this process. You'll need some table salt, which is sodium chloride, and you'll need some water. I'm using distilled water because the pH can really screw things up. And today it is about 50 degrees outside. If it's any warmer than that, you'll need some way to cool the solution as it goes, because at high temperatures, bleach, which is sodium hypochlorite, decomposes into sodium chlorate, which does not have disinfecting power. Okay, here we go. So this is distilled water. I'm going to make a saturated solution of salt. Oh, another detail. I don't think it will affect things much, but I'm using salt that does not have iodide added to it. Iodide is much easier to oxidize into iodine, and it will probably come out of the solution first. Not a big deal if you're trying to disinfect, but it's purplish black, and it will stain things, right? Now it's important to make sure these two electrodes do not touch. I'm using carbon electrodes. Metals will not work for this. Especially the anode, if it's any sort of metal, it will corrode. If you don't have carbon electrodes like this, you can take 2 graphite pencils and burn them to release the graphite from the pencil. It will work just as well. I've also seen exotic metals being used for this process. I believe iridium or platinum. Even gold will not work for this from what I've heard. So you'll definitely need to get a hold of some graphite. Okay, now watch carefully at the solution once I plug this in. I'm going to move upwind from this because this generates chlorine gas, which I don't want to be breathing. Ready? 3, 2, 1, go. So you can see bubbling coming out of the negative positive terminal, and a very little bubbling coming out of the red positive terminal. The reason is that at the negative terminal, both positive hydrogen ions from the water and positive sodium ions are migrating toward the negative terminal. The hydrogen ions become hydrogen gas. The sodium ions transiently become sodium metal, which reacts with water to make hydrogen gas. So all of those bubbles are hydrogen. At the positive terminal, chloride is migrating. Oh, you can see the solution turning a little bit yellowish green from the chlorine. Chloride ions are being oxidized into chlorine, which almost instantly react with the solution of sodium hydroxide from the positive terminal to make sodium hypochlorite bleach. I wish the camera could pick up odors to do this justice, but after the demonstration I'll bleach something for you guys to see that it actually is bleach. You can see a little bit of chlorine coming out of the whiffs of chlorine coming out of the top of the beaker. Okay, we'll leave it like that for a few minutes. Now, you'll just have to eyeball this, because if this goes on too long, the hypochlorite itself will be further oxidized to make chlorate, sodium chlorate, which again does not have bleaching powers. So a little bit of trial and error here. It's hard to say what concentration of bleach you're going to get out of this. Probably a lot higher than the stuff at the store because we're using saturated salt water. It's hard to say the exact amount because it's going to depend obviously on how long you run it, and also on the pH of the solution that you started with, especially if you're not using distilled water. It's going to depend on the ambient conditions of temperature and pressure. and a bunch of other effects right. Let's see if we can zoom in to some of those chlorine bubbles to see if we can tell the yellowish green chlorine. This is about as close I want to get to be comfortable with, hold on a second, let me see if I can get my zoom to work correctly.
And then I started more, so I was like, oh, this is so gross. Yeah. It's like, I cleaned your whole bathroom, but oh my God. It's only happened like
Alright, it's not going to do it. See, that dog could probably smell it. I can't smell it yet. I don't want to get any closer than this. Well, from the top maybe. Chlorine is heavy, so... Take a look at the other side with the hydrogen gas coming out of it. I don't know if my camera can pick it up, but I see whiffs of smoke coming out of the top, which is probably chlorine gas, because that's the only gas being produced that would have any sort of color to it. I don't want to get close enough to smell it. Oh, there's a nice bubble at the bottom of the anode. Let's see if we can zoom in on that to see if it's chlorine. There's two very nice bubbles down there. Come on. Come on. Yeah, my camera's not good enough for that. You know, I thought about this idea of having an electrolytic cell like this in your toilet, so then you can put salt in your toilet bowl. And every time you flush the toilet, it would make bleach in situ, right? Probably a lot safer than trying to add bleach yourself to the toilet bowl, right? I remember seeing a study that when you flush the toilet, particles shoot out in all directions, like at least 6 feet in all directions, right? And they were saying that was one of the risk factors. When I was in 8th grade, I used to have trouble remembering which color, red for positive and black for negative. I always got them confused. And one of the ways I remembered was that the positive terminal makes chlorine gas, right? I knew that, right? Because I knew chloride had a negative charge. And so it's dangerous, and thus positive should be red, right? That's how I remembered it. But it also makes oxygen, right? So it's a mixed bag, right? I guess the black one, it makes hydrogen, which can explode. So, well, explosion and black go better together, right? Poisonous gas and red, right? That's how I remembered it, at least. Okay, the solution's definitely getting a lot yellowish greener than earlier. Yeah, maybe in a future video, I'll think about tinkering with my toilet to have it generate chlorine in situ, like how I described. I think the big challenge is how long your electrodes are going to last in this kind. I'm surprised the electrodes are holding up very well. I did this with graphite pencils before, and they completely fell apart after like 10 minutes. And I think these electrodes, they came from China, so I'm a little bit. It's kind of surprising how much we depend on China for all our COVID supplies, right? The mask, the electrodes for making bleach, maybe even the Clorox bleach at the store. I'm not sure about that, but I wouldn't be surprised if the salt that was used to make Clorox bleach came from China, right? At least, right? Or maybe the electricity as well, right? And certainly that battery probably came from China. Let's see. Yep, made in China. Right there. Okay, a few more minutes and then I'm going to try to bleach this old sock of mine to see how well it discolors it. It probably is going to rip a hole in it because this is a lot stronger than your commercial bleach, being that it's made from almost saturated salt water. Okay, let's try bleaching the sock. I'm going to unplug it and give it a few seconds to vent off because I don't want to be breathing any of this stuff. Get everything out of the way. Let's see how I can position all this. Might take a few moments to settle in. Is it working? It's been a while since I did this, and last time I made a much weaker solution.
Hey!
These are very thick thermal kind of socks, so it might take a little bit. I think the problem might have been that I didn't stir it up after it was done. It wasn't very evenly. Well, it's a little bit discolored. I don't know if you can see it from the camera.